cubed theta d theta. Well, we know what secant cube theta is. Secant cube theta, I think that you have already evaluated, and that is in your table of integrals. Secant cube theta is just the sum of the derivative of secant plus the antiderivative of secant over 2. So that's one trick for you to remember. So, trick to remember. Secant cube theta d theta. Right? Equal to 1/2 antiderivative of secant theta d theta plus the derivative of secant theta. Okay? Right? So that's our way to remember. So what is the antiderivative of secant theta d theta? Ln secant theta plus tangent theta, right? What is derivative of secant theta? Derivative of secant theta is secant theta tangent theta. Alright? So there you go. That is secant cube theta integral secant cube theta d theta equal to this result. So now we just put it back in. Okay? So therefore, I is equal to 1/4 secant squared d theta tangent theta minus 3/4. We say this thing just equal to that thing, right? 1/2 ln secant theta tangent theta plus secant theta times tangent theta, right? Okay, so what does the question ask us? The question asks us to evaluate secant fifth theta over 4 d theta. So that equal to I over 4, right? So but you have I is equal to this whole thing. So therefore, I over 4 equals to 1/16 secant cube theta tangent theta minus 3, 4, that's 16, that's 32, right? Ln secant theta plus tangent theta plus secant theta times tangent theta. Alright? Okay, so that's your result. Alright? Okay. So now let's go to C. What does C ask you? Is there any question? Okay. So let's go to C. What does C ask you? C asks you to evaluate ln 16 plus x squared dx. Okay. So how do you do this? How do you do this? Well, you think that you cannot really find the antiderivative of ln function. There's no way that you can find that, right? You can only find its derivative, but not its antiderivative. So somehow you gotta transform it or change the way that it appears, or in fact use integration by parts, right? So let's just think of this as 1 times ln 16 plus x squared dx. Alright? So like I said before, if you're trying to use integration by parts, and you're trying to pick du and v, you're trying to pick du equal to something that is easy to find its antiderivative, right? Okay? So 1 is it's a function that is easy for you to find its antiderivative. And what is antiderivative of 1? Is x. So you put x, we set v equal to that, right? So ln 16 plus x squared, okay, minus derivative of v, which is dv, okay? We have u, so now we have du equal to 1, okay? du equal to 1, v equal to ln 16 plus x squared, okay? Therefore u is x, okay? So now this is u dv minus u dv. What is dv? dv equal to, and derivative of ln, we took the reciprocal, right? Reciprocal, so that's 16 plus x squared. But since there is a function inside, therefore we have to use chain rule. So we have to times 2x on the top, right? So 2x over 16 plus x squared. All right, so that's your dv times dx, right? Okay. So you put it in, which is x. Okay. dv, put it in, 2x over 16 plus x squared dx. This whole thing is dv, all right? Okay? So, okay, so how do you do this? Just simplify that, see what you can do from there. 16 plus x squared equal to 2x squared over 16 plus x squared dx. All right? All right. So we see that the top and the bottom. Well, we know this one is already done, right? It's just that is the, we don't have to touch it anymore. This one, we see the top, the power of the top is 2. The power of the bottom is 2. So we can do some long division, right? So just divide that. So what you get? Instead of dividing it, it sounds complicated. How about just set it equal to? Okay? You have a 2x here. So let's say you have 2x squared plus 32. But since you have a 0 here, so you got a minus 32, right? 16 plus x squared dx. Okay? That equal to 0. Okay? Well, separate them, right? You have 2x squared plus 32 over 16 plus x squared minus 32 over 16 plus x squared dx. Right? That's equal to x ln 16x squared minus, pull out a 2 on the top, 2x squared plus 16 plus x squared dx, minus a minus, that's a plus, 32 over x squared plus 16 dx. Alright? That equal to x ln 16 plus x squared minus, this cancel, right? So it's 2. So what is the antiderivative of 2 dx? 2x, right? Plus. Now, with this one, what do we say? We say we always think of trig, substitution. Well, is it necessary to do some trig substitution in here? You can, but I just want to recall you that, remember, that the derivative of tangent, inverse tangent u equal to 1 over 1 plus u squared. Okay? So that looks somewhat like that, not quite, right? Not quite, because this is 16 and this is 1. So that it's not quite the same, but we can make it the same way by doing this. How about just divide both by 16, right? Divide both by 16. But since we divide both by 16, we've got to times by 16, right? To compensate that, right? So x ln 16 plus x squared minus 2x plus this in there, that's 32 over 16, that is 2. Okay, 16 in here, that's 16, that's x squared over 16 plus 1 dx, right? Okay? You can write as what? You can write this as x over 4 squared, right? So, you see that now we have something in common. You look at this, and you look at that. We have something in common, right? So we have x over 4 equal to u, right? Okay? So you can let x over 4 equal to u, alright? So, let x over 4 equal to u, therefore dx equal to 4 du, okay? So therefore, integral of x over 4 squared plus 1 dx equal to 2 over u squared plus 1 times 4 du, right? That equal to 8 u squared plus 1 du, right? And we said it right here. We said it that tangent, inverse tangent u prime of that equal 1 over 1 plus u squared. Okay, so the antiderivative of this is just 8 inverse tangent u. Okay? Plus c. Right? So let's put everything back in. So we have this whole chunk up here. We evaluated this one, which is that thing right there. So the whole thing will equal to x ln 16 plus x squared minus 2x, alright, plus 8 inverse tangent u plus c. Now we have an x, and all of a sudden we have a u here. It's not homogeneous, right? It's not consistent. So let's just rewrite that. Plus 8. Let's just rewrite that. You have u is x over 4. We let u equal to x over 4 right here. Okay? U equal x over 4. So I just put it in there. So a inverse tangent x over 4 plus c. Alright? So that is your answer for c. Okay? So the rest are similar for D and E. So if you do them, they'll be following the same process. Okay? So with that said, I will do them and I will record them and put it online. If you want to have the solution for that, please email me. I will scan it and I'll bring it to you. Okay? So I'll give you the whole solution. For 14, let's do 14.